Hello everyone. So today we'll be studying a concept from exam P, which is an exam from SOA. Let's see. So the concept is independent events. What are independent events? So if you have, let's say, two events, A and B, we call that these are independent when the occurrence of one of them will not alter the probability. So one of the events occurring will not alter the probability of occurrence of the other event. So what does that mean? If let's say A happens, then this won't affect the probability of B happening or vice versa. So mathematically, these are the conditions. So this is what? This is the conditional probability of A given B. So given information of B, that is not affecting your probability of A. That's why this conditional probability is as good as the unconditional probability, which is probability of A, which means A and B, these are independent. Or in other words, you can say that B given A is same as probability of B. Or a more famous condition is that the intersection probabilities, they are just the product of the individual probabilities. So the probability of A intersection B, that is product of the probability of A and the probability of B. Similarly, B intersection A is the probability of B intersection times the probability of A. One major misconception which often happens is independent events. People think that this is similar to disjoint events. So what are disjoint events? Disjoint are basically, if you take a, let's say, via Venn diagram, we try to look at, let's say this is the sample space. Then within this, let's say we have two events called A and B. These are not disjoint because we see clearly there is a intersection part. But what are disjoint events is when we don't see any intersection part. So if this is A and this is B, then these are called disjoint events. Now, independent does not mean disjoint. There may be a case where you see that A and B, they are having a common region and still they are independent. Okay. So this may be the case and still they are independent. In fact, if they are mutually exclusive, then they are not independent. Why? Because you know that if A has happened, then clearly B won't happen. So that probability is not independent. It's in some sense it's dependent. Because as soon as information is given to you about A, that means you get to know that B won't happen. So that's not independent. But in this case, this is not, I'm not saying that this is how you see independent events visually. I'm just saying that don't get confused between independent events and disjoint events. Disjoint events are also called mutually exclusive events. So yeah, thank you. That's it about independent events.